Yeah, sir, you can tell briefly about you and then can start. Thank you, sir.
Okay. So, hello everybody. My name is Amit Khurana, and I have almost 12 years of teaching experience. I have secured under 100 rank in GATE 2020. My AIR was 94, and I'm teaching these subjects from the past 12 years. Okay, so just be with me, and you will get the clarity about the subjects. Okay. Yeah, so welcome to IIT GATE classes. So this is your lecture 1 on discrete mathematics. Okay, so discrete mathematics broadly speaking, discrete mathematics has 4 parts. First is logic, second is combinatorics, third is set theory and group theory, and the fourth is graph theory. Okay, so in the 4 parts, or you can say 4 modules, we are going to study this subject. And let me tell you one thing, this is the base of your computer science. Okay, this is base of your computer science GATE syllabus. If you know this subject, then you will be able to follow each and every subject. But if you are not able to follow this subject, then you will feel difficulty in each and every computer science subject. No doubt you will be able to understand the course or concepts and all, but you won't be able to solve questions, because GATE questions are mathematical in nature, and these mathematical in nature questions can be solved only by discrete mathematics. Okay, so this is the brief introduction, and this is one of the most important subject for your computer science syllabus. Okay, so let me brief you about all these 4 modules of this discrete mathematics. So the first module is logic. Okay, so from logic you can expect 2-mark question each and every year. 2 marks question come from this logic topic, but this year unfortunately no question came from logic, but indirectly there are lots and lots of questions which are from logic itself. For example, if you have studied about DBMS, then you have studied many theorems. Like one of the theorem is every conflict serializable schedule is view serializable. So this is a one-way theorem. So all these concepts will be used, or you can say will be derived from logic itself. So I will say every conflict serializable schedule is view serializable. This is one way theorem. If you do not know about what is conflict serializable, what is view serializable, don't worry about it. I will cover them in DBMS, or your concerned teacher will cover that. But I'm just giving you idea about where exactly logic will be used. So this is a one-way theorem. Now I will say 4 questions can come from this concept. So the question can be, every conflict serializable schedule is view serializable. Yes, this is direct theorem. Another can be contrapositive. Contrapositive means what? Not view serializable implies not conflict serializable. So the question will be, if schedule is not view serializable, then it will not be conflict serializable. This statement is also true, because these two are equivalent statement. And don't worry, I will prove each and everything in logic itself. I am just giving you idea. Okay, and next can be, if schedule is not conflict serializable, then it cannot be view serializable. This statement is false. Another can be view serializable. If schedule is view serializable, then it will be conflict serializable. This is also false. Okay, so if you are able to get something, then it's okay. But if you are not able to follow me, then please have some patience. I will clear each and everything. Okay, so the question is, every conflict serializable schedule is view serializable. This is you can say one-way theorem. Now the 3 questions can be asked. So directly you will say, if schedule is not view serializable, it will not be conflict serializable. Directly you will say this is true. Next, if it is not conflict serializable, then it is not view serializable. This statement is false. If schedule is view serializable, then it will be conflict serializable. Again, this will be a false statement. Okay, so another example can be from TOC. Like we say that if every
Yes.
finite language is regular. If we say every finite language is regular, again this is a one-way theorem. I am just giving you hint about how logic will be useful in each and every subject of your computer science. In DBMS, I have told you. In TOC, like we say that every finite language is regular. So this is one-way theorem. So again, I will say converse will be regular implies finite. Regular implies finite. This statement is false. So if language is regular, then it will be finite. No, I cannot say like this. If language is not finite, then it is not regular. No, I cannot say like this also. But if I say if language is not regular, then it is not finite, this statement is true. Okay, so the main concept here is that with the help of logic, we can easily derive things, that which statement is true, which statement is false, and so on, very easily, without even thinking about that. Okay, So if you do not know logic, then you will keep on struggling. You will keep on finding example that I will say that if it is not most serializable, then it is not conflict serializable. Okay, so you will keep on finding the examples or counter examples. But if you know the logic, you will directly say the statement is true. Okay, so are you able to follow me?
Yes, sir. Yes.
So it can be little slow.
Okay, okay. So
Yeah,
I
sure.
will speak a little slowly.
Yeah,
Okay,
sure.
so
Thank you.
okay, so now this is the basic introduction to logic. So the main application of logic will be you will be able to prove any statement true or false without even thinking about counter examples. You do not need to think about counter examples. You will directly say, okay, this statement is true. Okay, this statement is false. Okay, this is the beauty of logic. So if you know logic, then you will be able to solve most of the true false question in GATE exam. Okay, this is the best application, and do not think that only 2 marks question is coming from this topic, so it is not important and all. Please do not think like this. Okay, so it will help you a lot in many subjects. Okay, so next is combinatorics. Next module is combinatorics. You have already seen many questions in GATE, like how many. Okay, so you say how many conflict serializable schedules are present. Okay, or you say how in TOC you say how many DFAs are possible. Okay, how many NFAs are possible. In your data structures you say how many graphs are possible, how many trees are possible with 5 nodes, how many labeled trees are possible, how many unlabeled trees are possible, and so on. Okay, so all these questions are from combinatorics. If you know combinatorics, then you will be able to solve how many type of question very easily. Okay, so don't worry about it. I will complete this combinatorics in a very exhaustive manner, and I will solve lots and lots of questions in combinatorics, and you will feel this subject is very easy. Okay, so in GATE exam you do not need to think about anything. You just have to do mapping. I will solve each and every type of question in combinatorics, and you will just have to do mapping. And say you will say, okay, this is type 1 question. Okay, this is type 2 question. For type 2 question, this is your formula. Just apply the formula and you will get the answer. Do not apply any kind of common sense in combinatorics, because in GATE exam there are lots and lots of questions which require a lot of deep thinking. So I will cover each and every type of question, and you just need to do mapping. For mapping, how exactly mapping will be done? For that, you will need to do a lot of practice. Okay, you will solve all PYQs and all. You will be comfortable with this subject. And after doing, if you are comfortable in mapping, that's it. Just you need to do the mapping. Say you will find, okay, this is type 1 question. This is the formula, and you will apply the formula and solve the question. That's it. Okay, I do not require any kind of intelligence, or I do not require any kind of deep thinking from you. Okay, so but obviously I will prove each and everything, that how I am getting this shortcut, how I am getting this kind of formula, and so on. Okay, so don't worry about it. I will tell you each and everything in this subject. Okay, next module is set theory. Set theory is, you can say, it is a very vast topic, but I will call it as one liner. One liner in the sense, each and every question can be solved in only one line, or you can say one sentence. Okay, this is the beauty of set theory. So it is very vast, but it is very easy. So I will give you a kind suggestion that try to remember proof. Do not try to remember theorems. This subject or this topic will be having lots and lots of theorems. So do not worry about theorems, worry about proof. You will follow why. If you are able to follow why, then you will be able to follow what very easily. So you should focus on why, you should not focus on what. If you focus on why, you will be able to get what very easily. But if you focus on what, then you won't be able to get why easily, and you won't be able to solve GATE questions. The beauty of GATE question is that they will mingle up lots and lots of theorems. So if you are able to remember proof of the theorems, then you will be easily able to approach the question, and in at most 1 or 2 lines, you will be able to solve the question. Okay, this is the beauty of set theory. And you can expect 3 to 4 marks question from set theory. Okay, and sorry, I forgot to tell about combinatorics. You can expect 2 to 3 marks from combinatorics, but in GATE 2022, 5 to 6 marks questions came from combinatorics. So it's not hard and fast rule about how many questions will be asked from which topic. Okay, but it's the average, which I'm telling you, it's the average. Next is graph theory. Graph theory is again very important topic. Okay, and you can expect 2 mark question from this topic. Okay, and I'm giving you a warning that sometimes very difficult questions are asked from graph theory, and you will simply leave such questions. Okay, don't worry, I will cover each and everything in exhaustive manner. But if you think that you are not able to follow it, then you can leave it. Or okay, and we will not go into you can say dive deep into this subject, because you will cover this subject in pretty much detail in your MTech. Okay, so it's just introduction in GATE, and but the questions can be asked from any topic. Actually, it does not have any predefined or well-defined syllabus of graph theory. We do not have any proper syllabus. Okay, that's why questions can be asked from anywhere. So okay, so just leave it. I am just telling you that whatever I will be covering, that will be exhaustive, and you will be able to solve most of the questions. But my main concern is, do not try to focus on 100% question solving of graph theory. Okay, 100% questions solving is not necessary, really not required, because sometimes questions are very difficult, and in real time. Okay, the main thing is real time. When you are sitting in GATE exam, you have just 3 hours. And in 3 hours, you have to solve 65 questions. So in that situation, in that pressure, nobody is able to solve such questions. So just leave those. Okay. Okay. So this is the basic introduction to all the modules of your discrete mathematics. So we have 4 modules: logic, combinatorics, set theory and group theory, and graph theory. Okay. I have just given you basic introduction. Okay, so now I am starting the logic part. Okay, so let me jump to the slide. I think just a second. Yeah. So yeah. So this is the syllabus of your logic topic. First topic will be propositions. Next will be logical operators. Logical operators will be and, or, not, NAND, NOR, XOR, implication, double implication. Okay, please try to follow them. The first is and, or, not, NAND, NOR, XOR, implication, double implication. Should I say the name again, or is it okay to all of you? Should I write the names?
I got it.
Yeah, please come again.
Got it.
Got it. Okay. Okay. So next is next topic will be rules of inference. Next will be arguments. Then we will study quantifiers. Then predicate properties, and then translations. Okay, so I'm not giving brief introduction to all these topics. It will be just wastage of time. And whenever we will jump to the topic, I will give you a detail of all these topics. Okay, so the first topic which we are going to study is propositions. Okay, so let's jump to the slide. Proposition is what? Any declarative statement. Okay, please note down the definition carefully. Any declarative statement which is either true or false, but not both. Okay, this is the definition of proposition. So what is proposition? Any declarative statement. What is the basic meaning of declarative statement? Declarative means we are declaring something. That means you are getting some fact about from it. Okay, so factual knowledge, you are getting something. That is declarative statement. Okay, you are getting some knowledge. So any declarative statement which is either true or false, but not both. Okay, this is the basic meaning of proposition. So I am giving you some questions. So just try to answer them. First question is, moon is made of cheese. So see again, any declarative statement which is either true or false, but not both. So you should be able to assign truth value, that is either true or false, to the statement. So moon is made of cheese. Clearly this statement is false. So it hardly matters to me. It is either true or false. I am just giving you idea that, or you can say I am giving you or I am assigning a truth value to this statement. That means truth value of this statement is false. That's it. So this is a proposition. Next, Jupiter is made of gas. This statement is true. Okay, but see, we do not we are not concerned about truth value. It is true or false. We are not concerned about it. We should say that it should be either true or false, but not both. That's it. So hence it will be a proposition because we are able to assign a truth value. Next statement is Amit is tall. This statement can be either true or false. So see here carefully. Amit, it's a first person. According to English grammar, it's a first person. So it can be either true or false. It hardly matters to me. But this will be a proposition. But next statement, he is tall. He is second person. So it will not be a proposition. Okay. Please note this point. This is very important point. So Amit is tall. This is a proposition because we are talking about first person, and it's obvious that Amit is someone in your class and you are saying that Amit is tall. That's it. This statement can be the true or false, but not both, obviously. Okay. So this statement is proposition, but he is tall. He is tall. This is not a proposition. Okay. Because this is a second person. I do not know about whom I am talking. Okay. So there can be some group of persons, and in that group of person, and I'm pointing to somebody and I'm saying he is tall. So I do not know about the truth value. So it is not a proposition. Okay. Any query till now? Yeah, everybody, any problem?
No, sir. No.
No, sir. Got it.
Okay. Hello. Next, get out. So is this proposition? Tell me something. Are you able to find any factual information from it? So from here, no, yeah, we are not getting any factual information. So it will be not a proposition. Next, what a car. This is exclamatory sentence. So are you getting any factual information from it? Obviously no. So it is not a proposition. Who are you? This is a question. So obviously we are not getting any you can say any factual information. So it is again not a proposition. Next, sum of 2 and 3 is 5. Obviously we are getting some information that sum of 2 and 3 is 5. So this statement is true. No doubt this statement is true. So it will be a proposition. Similarly, sum of 2 and 3 is 6. Obviously this statement is false, but it hardly matters. I am getting some fact from it. So it will be a proposition. Okay. Yeah. Any problem till now? Okay. Yes. So next is sum of x and y is 100. What is this x and what is this y? I do not know about their values. So it won't be a proposition. Okay. Please note these questions, and I am jumping to next slide. Yes. Any doubts till now?
No, sir.
Yes. Any doubts?
No, no, sir.
No, sir.
Okay. Okay. Next, 4 is prime number. This is obviously I'm giving you some fact, or you can say I'm giving you some information. So this statement is obviously false, but it will be a proposition because I am giving you some factual information. Next, I have time and I will go to town. I have time. This is again a factual information that I am telling you that I have time. And this is I will go to town. This is again a factual information. So, and I have used and here. So this is a compound proposition, but obviously it is a proposition. And the type of proposition will be compound proposition. Next, tomorrow it will rain. Yeah, this is again. So tomorrow it may rain or it may not rain. I do not know, but the statement can be either true or false, but it cannot be both. Okay, so it is a proposition. Next is tomorrow it may rain. This may, it will create confusion in our mind. So it is not a logical statement. So it won't be a proposition. Next, everything is plant or animal. I am giving you a information, a factual information that everything is plant or animal. That's it. So this is a proposition. Next, my name is Amit. Again, this is a factual information. I am declaring that my name is Amit. So this is a proposition. So should I jump to next slide? Yeah, is everything fine?
Yes, sir. Yes, sir.
Okay, okay. Okay, so I'm jumping to next slide. This board is white. Again, this is a factual information. I'm telling you that this board is white. This is proposition. This is a book. Yes, this is again a factual information. This is a proposition. Okay, so I hope by all these examples, you are able to get idea about what exactly is a proposition. Okay. Yes. Is it okay?
Yes, sir.
Okay, sir.
Okay. Okay. So coming to back to our syllabus, proposition topic. First topic is completed. Now we are jumping to logical operators. Okay. Yeah. So let's jump to logical operators. Okay. Logical operators or connectives. We are calling them. Why we are calling them as connective? I will tell you. Okay. So logical operators or connective. See, logical. For studying logical operators, we should first know about what exactly is logical or propositional variable. Okay, in C language, we study integer variable. Integer variable will store integer value. We studied float variable. Float variable will store floating point values. Okay, in file also we study variables. So file variable will store information about file and so on. So what exactly will store proposition variable? It will store propositions. So P is a proposition variable which is storing I have time. Q is a propositional variable which is storing I will go to market. So P and Q. P and Q will be I have time and I will go to market. So this is a very big statement and I am showing it with the help of just 2 or 3 words or 2 or 3 letters P and Q like this. Okay. So this and is a logical operator. This and is a logical operator. Okay. So now I think you all have got idea that why I am calling them as connectives, because they are connecting two statements or connecting two propositions. Okay. Yeah. So in place of and, I can use or also. So P or Q will means what? I have time or I will go to market. So you may argue with me that, sir, this is not proper English statement. I have time or I will go to market and so on. But it hardly matters to me. Okay. Logic is not about making sense from English sentences. It's just like that only. Okay. So I have time or I will go to market and so on. So we can use like this also. Okay. So don't worry about it. So please do not try to make any sense out of them. Okay. Do not try to make any kind of sense out of them. It's just like that only. Okay. So if you are able to follow, then it's okay. But and I will give you lots and lots of examples where you will definitely say that, sir, we are not making any sense of English sentences, but still it is logical. Okay. Okay. So please note it down. I am jumping to next slide. Yeah. Till now, any problem? Any problem to anybody till now?
No, sir.
Any doubts? Okay. So should I jump to next slide?
Yes, sir.
Okay. Okay. So operators, broadly, I will classify operators into two categories: primary operators and secondary operators. Primary are and, or, and not. These are primary operators. And secondary are NAND, NOR, XOR, implication, double implication. Why I am calling them as secondary and why I am calling them as primary? Because from these primary, I can derive these secondary operators also. So you may argue that, sir, if we are able to derive secondary operators from primary itself, then why we are studying them? because they will make our sentences more meaningful and more short in length. Okay, that's why we are studying them. Otherwise, there is no use of studying them. We can do each and everything with the help of primary operators itself, that is and, or, and not. Okay, so broadly we have two categories, primary and secondary. Primary is and or not, secondary is NAND, NOR, XOR, implication, double implication. And don't worry about them, I will derive all these from primary, and I think you already know about them also. In digital you have studied, in Boolean algebra also you have studied them. Okay, so should I jump to next slide? Okay, so students, please be active. Okay, so I am jumping. Yes. So next is properties of basic or fundamental operators. Okay, we are going to study some properties of basic or fundamental operators. So what are the fundamentals operator? And, or, and not. Okay, so I will link all these things together so that you won't be able to you will not get confused in these topics from now. Okay, so in Boolean algebra we said this is and, this is or, and this is not. In set theory, intersection is just like and, union is just like or, and not is just like complement. In logic, we say x or y, x and y, not x. Okay, so these all are equivalent. These are very, very important points, and you just study one time and you will be able to follow three subjects very, very easily. X dot y is same as x and y, sorry, x intersection y, and it will be same as x and y. Sorry for that. Yeah, this. Okay, these are same. Okay, similarly, x or y, x plus y you say, or x union y you say, and x or y you say. These are same. So I am linking three subjects: Boolean algebra, set theory, and logic. X bar in Boolean algebra, X complement in set theory, not X in logic. These are same. Okay, these are same. Please note it down, and I am jumping to next slide. Show some quickness. Okay, we have just half an hour left, and I have to cover many topics. Please show some quickness. Should I jump to next slide?
Yes.
Yes, sir.
Okay. So now we will study truth table. Okay, truth table according to logic. In logic, we say true or false now. So we have two variables A and B, and we are assigning truth values. Say A and B are false. A is false, B is true, B is true. Sorry, A is true, B is false, and A is true, B is true. So A and B, I think you already know about it. Just for the sake of formality, I am doing. A and B will be false here. It will be false. It will be false, and it will be true. So how will you define and connected? And will be true when both are true. Or you can say and will be false if any one of them is false. Or, so or is here false, here true, true, and true. So or will be true when any one of them is true. Sorry, when any one of them is true, we will say or is true. Or is false when both of them are false. In case of and, but we will say and is false when any one of them is false. And is true when both of them are true. Okay, similarly, not is a unary operator. You already know about it. Not means what? A is false, then not A will be true. A is false, then not A will be true. A is true, then not A will be false. And A is true, when then not A will be false. Okay, so true to false, false to true, that is not. I hope you already know about it. Okay, so please note it down. I'm jumping to next slide.
Okay, sir.
Okay, yeah. So truth table for Boolean algebra. So so in Boolean algebra we use 0 or 1. So 0 in Boolean algebra. Okay, so in the previous slide itself, let me tell you something. In Boolean algebra, we will use 0 or 1. In set theory, 0 corresponding to empty set and 1 correspond to universal set. In logic, 0 correspond to false and 1 correspond to true. So all these are equivalent. Okay, so 0 in Boolean algebra, set theory, in set theory we use empty set, and in logic we use false. Okay, in Boolean algebra we use 1, In set theory, we will use universal set. In logic, we will use true. All these are same thing. So this is the beauty of the subject. Na? I am linking all these three things at a time. So you will study only one thing, that is logic, and you will be able to solve each and every question of set theory and Boolean algebra also. This is the beauty. Okay, please note it down. And I am jumping to next slide. Done?
Done, sir.
Okay. Yeah. So in Boolean algebra, so now we will say 0 means what? 0 means false and 1 means true. So again, A plus B. So 0 plus 0 will be 0. 0 plus 1 will be 1, 1, 1. And in and what we will say 0, 0, 0, 1. Not. So A bar will be 1, 1, 0, 0. Okay. So I think you already know these things. These are very basic things. But I am just, what I am doing is I am just linking all these three at a time so that you get crystal clarity. Okay. Done?
Done, sir.
Okay. Next, set theory. In set theory, see, I have already told 5 means 0 and U means 1. Okay. Or you can say 0 or you can say false, or 1 you can say true. So A union B. So 5 union 5 will be obviously 5. Okay. So union is just like or. So now you do not need to think about anything. You just copy paste U, and here also you do not think about anything. Just copy paste. A intersection B. Intersection is just like your and. So just consider them as false. So it will be false. So false true, it will be false. True false, it will be false. True true, it will be true. Okay. Complement means just reverse them. 5 will be converted to U. Okay. 5 will be converted to U. U will be converted to 5. U will be converted to 5. Okay. So I am just drawing U like this. It is not a standard symbol. Actually, when I used to teach, then many students got confusion about A union B. I am writing U here also and here also. So you may get confused. That's why I am writing U like this. Okay. So please note it down. Is it okay?
Yes, sir.
Okay. So I'm jumping to next slide now. So if anybody is not able to follow, or you think my speed is fast, then you can see the recording also. Okay. In recording, you can pause and take the notes properly. So it's just a demo class. So I just want to cover many things so that you get exact clarity about how I am approaching the questions, how I am, you can say, delivering the concept. So I am just giving you idea about how I am going to teach the subject. Okay. So you just focus on my teaching. That's it. Okay. So regarding notes and all, you will be able to, obviously, you will be able to note down each and everything properly from after seeing the recording. Okay. You can make the notes properly, and don't worry, this is not my actual speed. I am running bit faster so that I can cover many topics and you got clarity about how I am approaching the topics. That's it. I'm just showing you my skills and nothing more than that. Okay. So in actual classes, I will be teaching very slowly, and I will give you proper time to note down each and every slide. Okay. I will and even if one of the student will say, sir, I am not able to note it down, I will wait for that student also. So don't worry about it. Okay. Yeah. So I am jumping to next slide. Now we are jumping to properties of these your operators. Okay. Commutative, associative, distributive, identity, complement, idempotent law, absorption law, law of double complement, De Morgan's law, domination law. All these laws or all these properties we are now going to discuss, and I will discuss them according to only three operators, that is and, or, and, not. That's it. Okay. So in further classes, I will generalize these concepts also, but don't worry about them. I will just concentrate here on and, or, and not only. Okay. So uh, uh, do you want to note down all these laws, or should I jump to next slide?
Yes, sir. Continue.
Okay. So okay, actually it will waste time. You will keep on noting down all these things. So and obviously in each and every slide, I am going to cover one law. So obviously you will get the time. Okay. So first is commutative law. commutative law in logic, I will say P or Q is equal to Q or P. P and Q is equal to Q and P. This is in logic. What about my set theory? P union Q will be equal to Q union P. P intersection Q will be equal to Q intersection P. What about in Boolean algebra? P plus Q will be equal to Q plus P. P dot Q will be equal to Q dot P. This is commutative law. Okay, so I hope you have got it now. Commutative
sir.
means okay. Yeah. So should I jump to next slide? These are very
Yes, sir.
basic things, so we should not
Yes,
spend
sir.
time on it. Okay. Next is associative law. Associative law in logic, what will we say? In logic, we will say P or Q or R that will be equal to P or Q or R, like this. So we are associating the brackets. That's why it is called as associative law. Similarly, P and Q and R that will be equal to P and Q and R. That's it. In set theory, what will you say? P union Q union R that will be equal to P union Q union R, like this. P intersection Q intersection R that will be equal to P intersection Q intersection R.
R.
In Boolean algebra, P plus Q plus R that will be equal to P plus Q plus R.
R.
Okay. P dot Q, P dot Q dot R that will be equal to P dot Q dot R. That's it. So I hope you know all these things. These are very basic things. So should I jump
Yes,
to
sir.
next
Yes,
slide?
yes, sir.
Okay. So let me jump to the next slide. There is, I think, some problem in my software. Actually, it will take some time. Okay, so it's actually na. Yeah. So actually, I think yeah. Yes, distributive law. The distributive law is what in logic, what will say P or Q and R that will be equal to P or Q and P or R. Okay, P and Q or R that will be equal to P and Q or P and R. Okay, so what we call this, why we are calling it as distributive? Because OR is distributive over AND. We have distributive OR over AND, P or Q and P or R. Similarly, why we are calling it as distributive? Because AND is distributive over OR. So P and Q or P and R. So I think now by now you will be able to guess what we are going to do in set theory and Boolean algebra. It's simply wastage of time. So you in set theory, I am just writing shortly. OR will be replaced with union and will be replaced by intersection. In Boolean algebra, your OR will be replaced by plus and will be replaced by dot. So I think you can do yourself now. Or should I do it?
Yes, sir. Yes, sir. True.
Okay. So now I'm jumping to next slide. Identity law. See, identity law is what? Okay, so in logic, we will say P or true. Okay, P or true, or you can say P and true will be P. P or false will be P. Okay, so for and true is the identity. Identity in the sense whatever you are having here P will come as it is. Okay, and in case of or, false is the identity. False means what? Whatever you are doing here, okay, whatever you are doing here, P will be copy pasted here. That is the basic meaning of identity. And exact meaning of identity I will cover that in group theory. You will get proper clarity about what exactly is identity. I'm just saying that P is copy pasted. If we doing AND with true, then P will be copy pasted. That means P can be the true or false. So true and true will be true. True and false will be false. Let me say like this. Okay, P can be the true or false. So true and true is true. False and true is true. So what does this mean? Whatever you are, sorry, false and true is false. Huh? False and true is false. So whatever you have here, that will be copy pasted here. Okay. So hence true will be identity for AND. Similarly, false will be identity for OR. Okay. And in set theory, you will obviously say your OR will be replaced by what? OR will be replaced by union, and will be replaced by intersection. True will be replaced by universal set, and false will be replaced by empty set. So in set theory, what we will get? P and P is any set. Okay, P and universal set U, that will be P, or and in place of and we should write intersection. Na? We should write intersection. So you already know in set theory, any set intersection with universal set will be that set only. So for intersection, union is the identity. So for intersection, universal set U is the identity. Okay. Next will be P union phi, that will be P. So for union, phi will be the identity. Okay. Similarly, in Boolean algebra, what will you say? P dot 1, that will be P, and P dot 0, sorry, P plus 0, that will be P. Okay. So for dot 1 is the identity, for plus 0 is the identity. Okay. Please note it down. I am jumping to next slide. Is it okay? Yes.
Yes,
Okay,
sir.
sir.
Okay. So I am jumping to next slide now. Next is complement law. Complement law in logic says P or P bar, or P or P bar, that will be equal to true, and P and P bar, that will be equal to false. And this is very obvious also. Okay, see, P or P bar, either P or either P bar will be true. Okay, so if any one of them is true, that answer will be true only. So P or P bar will be true. Similarly, either P or P bar will be false. So P and P bar will be false. So if you are not able to follow, then I will make a truth table. Are you able to follow it? Okay, so let me make a truth table. True, false. So false, true. So P or P bar. What will you say? True, true. P and P bar. What will you say? False, false. So this is what I'm saying. Is it okay?
Yes, sir. Yeah, understood.
Okay. So in set theory, what will you say? P union P complement, that will be what? True means what? Universal set. Obviously, you know, na, set and its complement. You union them, you will get the universal set. Similarly, P intersection P complement. Both set will be disjoint. So your answer will be 5. Okay. In Boolean algebra, what will you say? P plus P bar, that will be equal to 1. P dot P bar, that will be equal to 0. In similar fashion, you can make truth table also. So this is your homework for you. P bar. So 1 0. Okay, true is 1, false is 0, and here 0 1. So P plus P bar, that will be equal to what? 1 1, and P dot P bar, that will be equal to 0 0. I have solved it also. So okay. So are you able to follow them?
Yes, sir.
Okay. So I am jumping to next slide now. Idempotent law. See, in many competitive exams, direct questions come. Okay, so idempotent law directly they will be asking. Idempotent law is A or A, that will be equal to A and A, that will be also equal to A. And it is obvious also. I think no need to explain it. Do you need any kind of explanation here?
Yes, sir.
Okay, so make a truth table. A, true, false. Again A,
False.
true, false.
False.
So A or A means what? True or true is true.
True.
False or false is false.
False.
So as it is copy pasted, A and A. True and true is true. False and
True.
false is false.
False.
So as it is copy pasted. Okay. So in set theory, what will you say? A union A will be A. You are doing union of two sets and both sets are same. Obviously, you will get A. A intersection A will be obviously A. In Boolean algebra, A plus A will be A. A dot A will be A. Okay. Yes. Should I jump to next slide?
Yes, sir.
Okay. So next is absorption law. Absorption law. See, this is very, very important law. In minimizations, we will be using this law many times. Okay. So what absorption law is saying? So let me do it in Boolean algebra because you already, I think you all are familiar with Boolean algebra. So I will say A plus A dot B, that will be equal to A dot A plus B, that will be again equal to A, and A plus A bar B, that will be equal to A plus B. So these are the three absorption laws. So how will you prove it? A plus A dot B is A. So I will obviously say, see here carefully, plus and dot. So you already know distributive law. Plus is distributive over dot. Okay, if you are not able to follow, please watch this distributive law. Actually, I have not given in Boolean algebra, but you are able to follow here, na? So see here. P plus Q and R is this. So in Boolean algebra, what will you say? Or is replaced by and is replaced by dot, or is replaced by plus, and is replaced by dot. So P plus Q dot R, that will be equal to P plus Q dot P plus R. Okay, this is the rule. Okay, so no need to copy. Actually, these and these are the same thing only. I have just replaced all with and so that you get a feeling about what exactly I'm going to do here. So P plus Q dot R is P plus Q dot P plus R. Okay, so see here now. See here. A plus A dot B will be equal to what? A plus A dot A plus B. Are you able to follow?
Yes, sir.
Okay, so what will you what are you going to get? A dot. Okay, so we do not need to follow this thing. Actually, I can take common also. Okay, so what I will do here to prove it, I can take A as common. From here, you can take A as common. What will you say? 1 plus B. And 1 plus B is nothing but 1 only, because see, we are doing OR. 1 is true. So B can be the true or false. So it can be anything. Na? 1 plus B you are saying. Na? So I will say 1 plus 0 will be 1. 1 plus 1 will be 1. Okay. So it can be either 0 or 1. It hardly matters. I am getting 1. So 1 plus B will be equal to what? 1. Actually, this is the next law, that is domination law. But to prove absorption law, we have used domination law itself here itself. So 1 plus B will be 1. So I think you are clear. So it will be A only. A dot 1. So A dot 1 is nothing but A only. Why A dot 1 will be A? Obviously, you know it. Identity law. See here. Identity law. P dot 1 is B. Okay. So are you able to follow it? Or you are feeling it a bit difficult? Yes, please tell me. Any doubt?
No, sir.
Okay. So A plus A dot B, I am just revising you. A plus A dot B. So I will take A as common. Here will be what? 1 plus B. So 1 plus b is nothing but 1 only. So a dot 1 will be a. If you are able to follow, then it's okay. Otherwise, leave it. I will again prove it. Don't worry about it. I will again prove it after completing all the laws. I will prove it. Don't worry about it. But just I will just tell you one thing. Why I am calling it as an absorption law? Because it has absorbed a dot b. A plus a dot b. So it has absorbed a dot b, and we are getting a only. Similarly, a dot a plus b. So it has absorbed a plus b, and we are getting a. Similarly, here also a plus a bar b. So it has absorbed a bar, and we are getting a plus b. Okay. So that's why we're calling it as absorption law. Okay, so I am not proving it because I think you all are getting you all are feeling that it's a bit difficult. So don't worry, I will prove it after few slides. Okay, after few slides I will prove it. Okay, so in logic, how will you say? In logic, you will say A or A and B, that will be equal to A and A or B, that will be equal to A or
Sir, voice नहीं आ रही.
Okay, voice is not coming. Yeah, I'm not audible.
You're audible.
Okay, okay. Okay, okay. So are you able to follow? A or A and B will be A and
Sir,
A
voice
or
नहीं आ रही आपकी.
Okay, but some are saying that I am audible.
So you're audible clearly. It's clear.
So please check your sound once, your speaker once. Should I continue? Yes.
Okay.
Now I am audible.
Yes, sir.
Okay. So you just replace it A or A bar and B, that will be equal to A plus B. Okay. Similarly, here also in set theory you can do yourself. Plus will be replaced by union, dot will be replaced by intersection. That's it. Okay. So please you can do yourself. Okay. Please complete these three things yourself, and don't worry about proof. I will come back to it after few slides. Please note it down carefully. Should I jump to next slide?
Yes, sir.
Okay. Next is law of double complement. Double complement law says it is very, very simple. A bar bar, that will be equal to A. Okay, so complement, see in set theory you will be able to follow. A complement you have find out. Now you are again doing complement. So obviously you will get the A. In Boolean Algebra, A bar bar, that will be equal to A. Should I prove it or you are able to follow it? See here, A can be the true or false. So A bar will be what? False or true. So A bar bar will be what? False, make it true, true, make it false. So see here, A and A bar are exactly same. A and A double bar are exactly same. Okay. So this is law of double complement. Is it okay?
Yeah, got it, sir.
Yes, sir.
Okay. Next is De Morgan's law. De Morgan's law is very simple. In Boolean Algebra, I will tell you in Boolean Algebra because you all might be familiar with it. So A plus B plus C plus D dot 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 whole bar, that will be equal to A bar dot B bar dot C bar dot D bar dot 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 dot. Okay. Next law is A dot B dot A dot B dot C dot D dot 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 bar, that will be equal to A bar plus B bar plus C bar plus D bar dot 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 dot. Okay. So shortcut to remember is change the sign, break the line. See here, A plus B bar. So change the sign, change this sign plus 2 dot and break the line. So break this line. Okay, break this line, change the sign, a dot. So a plus b whole bar, that will be equal to a bar dot b bar. Okay, are you able to follow it? So this is De Morgan's law. Similarly, if I say a dot
Again, voice
b,
is not coming.
okay, again voice issue. Everybody is facing the same issue, or only your name, Vikas?
No, sir, it's clear for me.
So I'm not
Okay,
facing
so
anything.
Vikas, I think you should. I think your internet connection is not working properly. That's why you are facing these issues. Don't worry, Vikas. You can watch my recorded session. So please, let's not waste the time in live session itself. Okay, so try to watch my recorded session. Okay, yeah. So a dot b bar. So again, change the sign, break the line. So break the line and change the sign. So it will be like this. Okay, so a dot b bar, that will be equal to a bar plus b bar. Okay, so yeah, so this is De Morgan's law, and you can generalize it in logic. In logic, what will you say? A or b or c or d dot 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 whole bar, that will be equal to a bar and b bar and c bar dot 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 dot. Okay, and d bar dot 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 dot. Okay, and a and b and c and d dot 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 bar, that will be equal to a bar or b bar or c bar or d bar dot 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 dot. Okay, similarly you can copy paste in set theory also. Just replace or with union and with intersection. That's it. Okay, so I hope you are able to follow it. Is it okay?
Yes, sir.
Okay, so next is domination law. Domination law means, which I was talking previously, dominate. Something will dominate another thing. So I will say p plus 1. Oh, in logic, na, first let's see in Boolean Algebra. P plus 1 will be 1. P dot 0 will be 0. Okay, so how will you prove it? I will say this is OR, na? This is OR. Okay, see here carefully. This is OR. One of the input to OR is 1. You do not need to see other input. You will directly say answer will be 1. Similarly, this is AND. Na? One of the input is 0. You do not need to see other input. You will directly say it 0. Okay, how I am saying it? I am saying it from the truth table itself. If you are not able to follow, see here truth table. See here truth table. See, in case of OR, if one of them is 1, if one of the input is 1, you forget about the second input, you will directly get the 1. In case of AND, if one of the input is 0, you forget about the other input, you will get the 0. Same is the case here. So I am saying it domination law, because it has dominated. So 1 has dominated p, 0 has dominated p, and you are getting here 0 and here 1. If you are still not able to follow, then I will make a truth table for you. So p can be either 1 or 0. 1 is obviously 1 and 1. So p plus 1, that will be 1 plus 1 is 1. 0 plus 1 is 1. So what you are getting? P plus 1 is 1 only. Okay. Similarly, similarly here I am giving you proof. P can be either 1 or 0. 0 can be obviously 0 or 0. So p dot 0. So 1 and 0 is 0. 0 and 0 is 0. So finally you are getting 0 only. So p dot 0 will be 0. P dot 1 will be 1. In logic, what will you say? P or true, that will be equal to true. P and false, that will be equal to false. In set theory, what will you say? Any set P union universal set, you will get the universal set itself. And P intersection phi empty set, you will get the empty set itself. That's it. Okay. Yes. Any doubt?
No, sir.
Okay. So now we are jumping to gate questions. Okay, so just bear with me for only 5 minutes. Okay, so you just get the flavor about how exactly things are going to work here. So I'm just giving you small idea about the question. GATE 2008 question. This is very difficult question if you do not know my basic things. You will keep on making Venn diagram and you will keep on wasting the time because it's intersection, complement, and so on. You will think that it is a set theory question and you will waste a lot of time in GATE exam. But I will prove it with the help of Boolean algebra in few seconds. What I will say, PQR, directly I will say PQR plus P bar QR plus Q bar plus R bar. I have just changed it into Boolean algebra. Now what I will say, see from here, are you getting something common? Yes, I am getting Q bar as QR as common. QR as common. P plus P bar. What is P plus P bar? You already know it is 1. So QR dot 1 plus Q bar plus R bar. Okay. So QR dot 1 is nothing but QR plus Q bar plus R bar. Okay. So please do not get confused. Actually, I have done a small mistake. Here I have used small letter and here I have used capital letter. So it hardly matters. So let me do it properly. Q bar R bar. And here also Q bar R bar. Okay. So Q bar plus QR. What will you say? So is it okay or I'm moving a bit faster? Are you able to follow till now?
Yes, sir.
Okay. So now here I will use absorption law. I have told you P plus P bar R, that is equal to what? That is equal to P. Okay, or let me prove it here itself. Okay, or let me jump to the previous slide. I will prove it properly. Now you are, I think, enough mature. You will be able to follow each and everything. A plus AB is A. How I am proving it? I am just taking common A and I am saying here 1 plus B. 1 plus B domination law. According to domination law, I will get A dot 1. That is nothing but A. First law is proved. What about my second law? A dot A plus B is A. So how will you prove it? I will simply say, just open up the bracket because of distributive law. A dot and here plus na. Dot is distributive over plus. Just open up the bracket. You will get A dot A plus A dot B. Okay. Now A dot A is what? A dot A is what? A plus AB. Again, same thing. A plus AB is A only. So you will get here A. Okay. And since you are in initial stages, so you should label each and everything. Okay. So it's your homework. You will say 1 plus B. So how exactly I'm getting 1 plus B? So let me do it one more baby step for you. A plus A bar B, na? Sorry, A plus AB, na? So I will say here, I will say A dot 1 plus AB. And you will say why A dot 1 is A. Okay, you have to label in bracket, you have to label the name of the law, that why I am calling A dot 1 as A. This is identity law. So you will write, this is your homework for you. And if you are able to write each and everything, then you will pick up more speed. And why I'm able to solve in very faster manner, because I'm teaching this subject from the past 12 years. So each and everything is properly fitted in my mind. So you so how each and everything get fitted in my mind? I just keep on solving things, just keep on explaining the laws and so on. I will get everything get fitted in my mind. Same is the case, same case should be followed by you also. You will have to write again. Each and everything you have to write many times, and then you will be able to follow each and everything, and you will gradually pick up more and more speed. So it's your homework. You will write A dot 1 and A dot 1 is equal to A. You will write the name as identity law. Now A dot 1 plus A dot B. Now I will take A as common and I will say 1 plus B. Now you will write the name of this law. 1 plus B is 1. Why 1 plus B is 1? Because of domination law. You will write here in the bracket and you will say A dot 1 we are getting. So A dot 1 we are getting and A dot 1 will be A. And why A dot 1 will be A? Because of identity law. Like this you have to prove. Okay. Now here A dot A plus B is A. A dot A plus B is A. So I will write A dot A plus A dot B. A dot A is A. Why A dot A is A? Law of which law? Please tell me. A dot A is A. Which law? Idempotent law. Idempotent law. Okay. A dot A is A. A plus AB is equal to A. So A plus AB is equal to A. Again, I have already told you absorption law. Okay. So we are getting A here. Now A plus A bar B is equal to A plus B. How will you prove it? A plus A bar B is equal to A plus B. How will you prove it? I will simply say here plus and here dot. Plus is distributive over dot. So I will write A plus A bar dot A plus B. And what is A plus A bar? A plus A bar is 1. Which is this law? Law of complement. 1 dot A plus B. Now 1 dot A plus B will be A plus B only. Which is this law? Identity law. So I will get answer as A plus B. Now another law can be, in place of doing this, okay, I can also say A bar plus A dot B. Please answer me. What will be the answer here? A bar plus AB will be what? Yes, anybody? Nobody? Yes, at least say no, sir. We are not able to follow. Then I will repeat again and again. Please tell me something. Yes, I am audible.
Yes, yes, sir.
Hello.
I am audible to you.
Yes, yes, audible.
Okay. So A bar plus AB, again distributive law, plus is distributive over dot. So what I will use, A bar plus A dot A bar plus B. A bar plus A is nothing but 1. 1 dot A bar plus B. So finally, what we will get? We will get A bar plus B. Is it okay?
Yes, sir.
Okay. Okay. So now we will jump. Do you want to note it down, or you will note it down from recorded session?
We'll take from recorded session.
Okay, okay. Yeah, you can take the notes from recorded session. Now I am jumping here. So see here, I'm getting now just try to focus here. Okay, now just try to focus here. What we are getting, Q bar plus QR. We will directly write, what we will directly write, Q bar plus R. Again plus R bar. R plus R bar is 1. 1 plus Q bar, it will be 1. Okay, and it's your homework. Please write down all the names of the laws which I have used here. Answer is 1. 1 is according to your Boolean algebra, but the question was of set theory. So in set theory, 1 means what? Universal set U, and 0 means what? 5. So finally here answer will be universal set U. This is very difficult question. If you try to make Venn diagram and all, you won't be able to follow. But see here how easily we are getting universal set. And I know you may be facing some problems here because you have not done practice and all. But once you will be able to follow, and once you keep on writing all the laws, you will get crystal clarity. Okay. So like this, you have to write P plus P bar is 1. This is what? Complement law. Right here, complement law. Okay. Now this is what? A kind of absorption law. It is not exact absorption law, but it's kind of absorption law. And we are getting Q bar plus R here. R plus R bar is 1. R plus R bar is 1. Again, complement law. 1 plus q bar is 1. Domination law. Like this. Keep on writing the name of the laws. You will get each and everything. Okay. Is it fine?
Yes, sir.
Okay. So should I leave the session or we should practice more questions? Yes, please tell me something. Should we stop the lecture here itself? At least say yes or no. Whatever you will say, I will follow. Okay, so I think everybody is thinking, sir, time already ho gaya hai. 15 minutes are already you have taken more 15 minutes, so you should take the break. So is it everybody thinking like this only? Yes. Okay, so let me leave the session here itself, but please try to follow something. Okay, so please take the proper notes from the recorded session, and this is your next question. Try to follow it. Try to minimize it yourself, and in the next lecture itself, I will explain you. Next, see also this. Try to minimize it. Okay, and one last question. One last question. Okay, so let me jump to the next slide. Okay, so this annotations are coming and I'm not able to go to next slide. So just wait for a minute or few seconds. Yeah. So this question also, just try to minimize it. That's it. Okay. So thank you all of you. So hopefully we will meet in the next class soon. Thank you. Yes. So please, anybody, if you want to give me any kind of suggestion, then you are most welcome. Or we should end the session now. Okay, so should we end the session?
Sir, one
Okay, sir.
query, sir.
Yeah. Tell me.
Sir, when will we be getting the recorded session, sir?
I think in half an hour on the website itself, you will get the session. I hope so. Or you can say, I will, do you have a number uh, of the concerned teacher?
Who,
The
sir?
teacher who was taking your class, I think Nivesh Sharma. I forgot the
Okay.
name.
Even I don't know.
So do you have his contact number?
No, sir. No.
Okay, so how will you get the session? This is a good question. So let me ask the sir itself. Just wait for a second.
Okay.
Yeah, I am asking sir. So please wait for a second.
Yeah. Okay.
I think sir must be having your contact numbers, na?
Dinesh sir, you're asking, sir?
Yeah, Dinesh sir.
He's having.
Okay, so he will send you the, I think most probably he will send you the link on the WhatsApp itself. Okay.
Okay, sir.
Okay then. Thank you so much. Bye bye.
Thank you, sir.
sir.
Okay. Bye bye.